Hello, welcome back. Today we'll be talking about key words to be on the lookout for when you're working on your combinatorics questions. Let's first talk about whether order matters in your counting question. Remember that when order matters, we end up counting things like lists. And when order doesn't matter, we end up counting things like sets. You'll end up counting things like lists when you see questions like, in how many ways can you order some collection of things? Or in how many ways can you arrange some collection of things? Also, when you see questions asking about passwords or words, those can be thought of as lists of characters. On the other hand, if your question starts out, in how many ways can you choose something? Often that's asking you for a set. Or, how many collections of certain sets of objects are there? Or how many choices are there of different types of objects? Those are going to signal that the underlying object you'll be counting are sets. You should always pay attention to the wording because seeing a word like choose may simply mean that you have a counting problem. It might say, in how many ways can you choose an ordering of 5 people in a row? In that question, it's asking for an order, so that's telling us we need a list and not a set, even though it used the word choose. And then be aware that most questions involving food are talking about sets. If you're ordering cookies, if you're ordering bagels, if you're going to McDonald's and ordering food, it doesn't matter how they place the food on the tray, and so that means we have a set, not a list. But again, read carefully. There may be an explicit ordering on your food. For example, making an ice cream cone with purple, pink, and green scoops in one order may not be the same as an ice cream cone with green, purple, and pink scoops on the top. All this will depend on the context of the question. Next we can ask, are we dealing with distinguishable or indistinguishable objects? You may also have seen the words distinct and identical to mean the same things. Some objects are by their nature distinct. People. Each person is different. A collection of numbers. The number 1 is different from the number 2, is different from the number 3, etc. Letters in an alphabet. Each character in an alphabet is different. Even if you take this set of distinct objects and you partition it into groups by some property, for example, hair color, we still expect the elements in each of those two groups to be distinguishable from one another and between groups. On the other hand, some objects are made to be interchangeable. You go to the store and you order one bagel, they could take any bagel out of the bin and it's considered to be the same bagel. It's the same thing with items that are manufactured. A large pile of marbles. Every marble that runs off the manufacturing line is expected to be the same. And then if we think about chairs, every chair can be considered the same as every other chair. However, sometimes identical objects are given properties to distinguish between them. There are sesame bagels and there are plain bagels. There are yellow marbles and there are blue marbles. There's the first chair, the second chair, the third chair. When you have two identical objects that have different properties, they're considered to be distinct from one another. But there's still the expectation that when you have two identical objects with the same property, they are identical. 2 sesame bagels are identical. 2 yellow marbles are identical. It's worth mentioning that there's an ambiguity sometimes. Some objects can take on the role of either distinct or identical objects. It will depend on the context. Often it comes down to whether the objects are thought of as individuals or as part of a collective. We can see this in the following 2 examples. In this first question, in how many ways can we give food to these 10 cats in order, we're thinking of each cat as being an individual. And so giving food to cat 1 and then to cat 2 is different from giving food to cat 2 and then cat 1. On the other hand, in this question, in how many ways can 4 orange cats and 3 black cats be arranged in a line, we're thinking of the orange cats as being indistinguishable from each other and the 3 black cats as being indistinguishable from each other. So even though in both questions we're talking about some number of cats, in the first question we're thinking of them as individuals and therefore we think of them as distinct, whereas in the second question we think of them as part of a collective and therefore as identical when they share the same property. The last question I want to discuss is whether you can repeat elements in a larger group. So either repetition is not allowed or repetition is allowed. How can we determine if, in our question, repetition is not allowed? If our underlying objects are distinguishable, and you are constructing a list or set where the presence of one object impacts whether that same object can appear later, then repetition is not allowed. We can think of this in terms of humans in a race. Once a person comes in 16th place, they're not going to come back in 32nd place. Similarly, subsets of 1, 2, up to n. In a set, an element cannot appear multiple times. And then ordering your books on a shelf. Once you place one book in a particular position, it cannot also appear in a different position. On the other hand, if your underlying objects are distinguishable and the presence of one object doesn't impact its reappearance, then repetition is allowed. Think about these examples. Your workplace has an employee of the month. You can be employee of the month this month and next month. Letters in a password. Normally you can repeat the same letter multiple times in the same password. Then there's our friend the multiset. The number 2 can appear 10 times in a multiset. Or bagels in a bag, right? So even though bagels themselves are identical, there are distinguishable types of bagels. It's also worth noting that in both of these cases, we're thinking about distinguishable objects or distinguishable types of objects. And there's a reason for that. If every underlying object looks the same, then making a list or a set or a multiset will also always look the same. And it's worth noting that the wording of the problem can turn any question where repetition is not allowed into a question where repetition is allowed, and any question where repetition is allowed into any question where repetition is not allowed. Let's say we're talking about humans in a race where they're running around a racetrack and where a person can go through a finish line multiple times. Then repetition would be allowed. What if we're talking about a subset where repetition is allowed? That sure sounds like a multiset. And what if we have books on a shelf where we have multiple copies of the same book? In all those cases, repetition is now allowed. On the other hand, you might make restrictions where a person who wins Employee of the Month cannot win it again. Or if you use a letter and a password, you cannot use it again. Or you have a multiset where no element can appear twice. That sure sounds like a subset to me. And you can have bagels in a bag where you can only have at most one of every type. That type of context has changed whether repetition is allowed or not. So the moral of the story is read carefully. Make sure that you're reading the problem very carefully, you digest it, and you understand what you should do. The next video shares some key insights about problem-solving strategies. It was made at another institution, but the ideas are just as relevant for our class. See you next time.